All right, this section is about intermediate topics in Excel. And there's a number of short reading links here. So nesting functions part one, oops, that should be nesting functions part two. Drop-down lists, data validation, automatic data entry, and autocomplete. All of these are short reads. And I have a file here, nested functions, dropdowns, and autocomplete.xlsx. And that is my own spreadsheet with some samples that you can see how I've actually done some of the things in these files. In addition, I have an Excel spreadsheet here with some date and time related functions that I'll show you, and something from Microsoft. This is just a page taken right off of the Microsoft's website with some other functions. There's a whole lot of things you can do with dates and times. So let's get started. Very first one, nesting functions in Excel. And again, this is just a short read, but nested functions is when you have a function inside of another function to perform some task. So nesting refers to using a function as one of the arguments inside of another function. An argument is just a piece of information that's necessary to complete a function. So when do you use nesting? Nesting functions are useful when you need to make several calculations to get to your desired answer, but don't need to see the results of those steps as you go. So you're trying to do basically multiple functional calculations in a row, or maybe one function depends on the answer to another. And I'll show you some examples. And so again, you can read through this probably once really quickly to get an idea, and then another time after you're done going through some of my examples, go back and read this again. I think it'll make more sense after you've seen some examples. But in this example, we have, and I don't know if this link is still active, it doesn't matter, but you can recreate some of the stuff here. But the worksheet has the numbers of students selecting apples, bananas, carrots versus donuts and cookies, the healthy versus the unhealthy choices. And so we might look at, we want to know how many more students on average choose sweet snacks instead of healthy snacks. Well, first you need to know what sweet and healthy are. So there are different ways to do this. And you could look at the average numbers of healthy snacks, the average number of healthy snacks and unhealthy snacks. You could average them all as you do down here. But then you can do the average between the healthy and the average of the unhealthy by first looking at the sweets versus the healthy. The sweets are the donuts and cookies. The healthy are the averages of apples, bananas, and carrots. And so you could look at those in terms of the average numbers of total numbers of sweets. So you're adding up the average. This is not average for the averaging the sweets. This is the total of the averages. Anyway, you can follow through their logic here and take your time. I don't want to spend too much time walking through this particular example. I've got a bunch of examples to go. But rather than doing it step by step like they did there are other ways to look at it. And so you could actually look at it in different types of calculations. And this just takes some time. You got to play around with it and wrap your head around some of these equations in terms of how they came to the same difference number in a nested function. And they show you here, and I'm not going to piece this one or tease this one apart and walk you through it. I want you to read this and walk through it on your own. I'll walk through some other ones. Then there's a second one on nested functions. And this one's directly from Microsoft. Here's an example of a nested function right there. The if function basically says if, and then here's the first argument, if the average of cells F2 to F5 are greater than 50, that's the first argument or piece of information. In this case, it's a logical test. If F2 through F5 average is greater than 50, then you do something. If it's true, then the result you turn back is add up G2 to G5. So if the average of F2 to F5 is greater than 50, then return the value, if that's true, return the value of the sum of G2 to G5. And if you put this in the cell, that's exactly what you'll get. If it's not true, if it's not greater than 50, if it's 50 or less, then it's going to return a value of 0 in the cell with this function, this nested function. Because you have an if function, inside of that if function, I have an average function and a sum function. And I use probably more if functions nested than any other function. It's really, really handy. If this is true, then give me this. If it's not, give me that. All right? Again, you could put some numbers, just open up an Excel spreadsheet and put in some numbers into F2 through F5 and some numbers in G2 to G5 in a spreadsheet, any numbers, and then put this equation, this formula, a formula, or casually speaking, an equation, but it's really a formula, into any other cell and run it. And you'll see that if the numbers you chose to put into F2 to F5 are greater than 50, it will add up these numbers. Then change the numbers. You know, if the numbers you chose were add up or average greater than 50, then make them less than 50. Put different numbers into F2 to F5 and try it. See what happens. And you'll see that if it's greater than 50 in the F column, this cell will return the total of the G column. Otherwise, if it's not, it will return a 0. So again, that's I think a really clear example of how that if function might work. And it also talks about, not talks about here, but shows you an example of what I'm talking about with arguments. The arguments, there are 3 arguments here, 3 pieces of information. The logical test, number 1, what to do if it's true, argument number 2, and what to do if it's false, argument number 3. And in the generic sense, all Excel functions have arguments based on, you know, the information you need. Sometimes the argument is a logical test. Sometimes the argument is a mathematical formula. It can be anything. So take a look at that, maybe play around, open up Excel or your own spreadsheet and see what happens when you do this. All right? Then the next one, C. This one actually talks about drop-down lists. So before I get to the drop-down lists reading, let me open up my sample file. With nested functions. And I'm going to enable editing, and I'm going to view, zoom, And let's make this one 180% zoom. There, that's easier to see. So I have in this particular table, I've got a group of salespeople in East, West, North, and South districts. And so their district is identified. What were their sales for whatever period, doesn't matter. And how far are they, or how long have they been employed? And so I have column E is a 2 if both criteria are met. And actually, where'd my criteria go? Well, I can see the criteria in the equation here. So if D5 is greater than 5, so in other words, if the employment years is greater than 5 and C5, their sales is greater than 10,000, give them a 2. This one has 2 functions that have to be met, 2 criteria that have to be met. So the AND function, I can list 30 criteria if I wanted to. In this case, I'm doing 2. We've seen the AND function once before, and the AND function returns a simple true or false. That's all it does. But if you use the AND function, every single criteria has to be true. And I can keep adding commas with different things. In this case, I've added 2. If D5 is greater than 5, so that means employed for greater than 5 years. Not greater than or equal to, greater than 5. So 5 doesn't work. It has to be 6 or more. Or even 5.1 if I had fractional years. So if it is true that they've been employed for greater than 5 years and C5, they have a sales that's greater than 10,000. So again, they can't have a sales of 10,000. They can have $10,001, but it has to be greater. Then they're going to return a value of 2. If it's not, they're going to return a value of 1. That's what this equation says. It's a nested equation using an AND function nested into the IF function. So let's look at this. Are they employed for less than 5 years? No. Do they have more than $10,000 in sales? Yes. So only one criteria is met. They get a 1. What about the second person, Joe? Is he more than 5 years? Yes. More than $10,000? Yes. The function returns a 2 because both criteria are met. Bill, doing great with sales, but doesn't meet 5 years. They get a 1. Bill gets a 1. Mary, 12 years. She meets the 5 years and she meets the $10,000. No problem. Mark doesn't meet the sales. John doesn't meet either one. And Ted meets sales but doesn't meet the years. Okay? So this is returning a job level or something. And you might have something like this that could be bonus, tied to bonuses, tied to sales assignments. There could be any number of reasons you ask questions like this. And you don't have to say, is this a valid question? You can make up your own. The concepts of these equations or functions, formulas, excuse me. A function is, in this case, we've got 2 functions, the if function and the and function. The whole thing together is a formula, all right? And please forgive me, I do use my language sometimes too casually. But you can use the same concept to come up with anything you want. Now, what if, for example, this employee was here for 5 years? It's still 1. Unless I change this to greater than or equal to 5. Greater than or equal to, you just use the greater than sign and the equal to sign, Bingo, she just became a 2. Linda's now a 2 because 5 counts. Without it being greater than or equal to, she only gets a 1. All right, that's really important when you're setting up your own equations. Is it truly greater than, or is it greater than or equal to? And there are so many cases where you need to test your formulas that you come up with and test them in the most extreme way possible. What happens if somebody's right on the border of a 5 or a 10,000? Does it do what you want it to do? What if somebody lost $20,000 and they've got a negative number there? Does your formula still work with a negative number? In this case, it would, but any formula you have, double, triple, quadruple check it with every worst case scenario of data that might throw your formulas off. Always, always, always double check them. Now over here, I have an AND function only. I've taken the AND function out of the nested equation just to see what happens. AND only returns true or false. It's true if every one of the arguments is true, all of them, and. That's why it means and, or the function is named and, because it means all of them. This one and this one and that one and that one all have to be true. And if they all are true, then it returns the value of true. And so in this case, it's false, she gets a 1. It's true, he gets a 2. It's false, a 1. So I could use the AND function to come up with the same thing, but I would end up with true and false instead of 1 and 2. And if I need to do a calculation on this after the fact, if they're bonus, for example, people who have a 2 get a double bonus for that week or whatever, then I need a number 2. If I need to do math on it, I need a number. But I could actually return anything. You know, if it's true, return blue, and if it's false, return zebra. Doesn't matter. It's zebra because it's false. But if she was there for 6 years, it's blue. I can return anything I want with that if function. But if I want to do math on it, I have to return a number. Or at least if I easily want to do math. There's always ways around it. So that's one example of using a nested if function. What if I wanted either one is met? They either are there for more than 5 years, or they sold a total of more than $10,000. Well, in this case, what have I done? Instead of the AND function, I used the OR function. That's an either or. Any one of the arguments is true, and it returns a positive statement. It returns a true. So there's the OR statement taken out. If either one of them is true, then the whole thing is true. It only needs one. The only individual is John, who not only hasn't been there for more than 5 years, has not had sales of this time period of more than $10,000. The only one where the OR gives a false is for John. But again, I've got a nested function. I just say fifth argument, is this true? And what am I testing? The OR statement. Either they've been employed for more than 5 years, or they've had sales of more than $10,000. If one of those is true, return a 2. If neither of them is true, then return a 1. And again, that 2 and the 1, I just, like I showed you before with blue and zebra, I can return any number, any word, anything I want. I could even return something, I don't know why I would do this, but I could say sum D16 colon D22. So if these things are false, I'm going to sum it and if they are true, I'm going, or excuse me, if it's true, I'm going to sum it. If it's false, I'm going to average D16 colon D22. Now, clearly, that's not the total of this column. It is the average. Now, this one's the total of the column, 34, because it is true. Does that make any sense to do that in this particular case? No. I'm just trying to show you how I just made, there's that ugly formula, how I made an ugly formula with an OR, a sum, and an average all nested inside of an if function. If either of these statements are true, then return the sum of the column D. If neither of them are true, return the average of column D. Again, you have to think what the logical formula is to use. My job is just to show you how they might be constructed. Well, column E now has both criteria are met. You get a 3. One criteria is met, either one, you get a 2. And if neither is met, you get a 1. So now there's a 1, 2, and 3. I've got it even a little more complicated. So let's look at the formula I have here. And if, and this gets a little complicated here, but it's not that hard. If you play with it and think about it, if both, because I'm using the and function, if both the employee is employed for more than 5 years and has sold more than $10,000, return a 3. Okay, so far it's exactly the way we have talked about this. If both of these tests are true, return a 3. Otherwise, go to the next step. And this entire next step is the what to do if it's not true. If the and function for both of these is not true, what do? You go to another if function. All right, if either of them is true, return a 2, otherwise return a 1. Take some practice. Some people wrap their heads around these kinds of things really well, and some people have to work at it. And some people say, I'm never going to get that. To which I'll say, I'm never going to ask you to do this on a test. All right? Do not stress. I'm not going to ask you to do this on a test. All right? And then the last one here on this tab, column E is 4 for east, 3 for west, 2 for north, 1 for south. So the job, oops, escape. The job level really isn't about a job level. It's turning a word into a number. So I said earlier, if you're going to do math on it, you need to have the arguments return a number. You can do it later if you want to. If you want to return a word and then later convert a word to a number, here's how to do it. If their district is east, return a 4. Otherwise, go to the next step. If the district is west, return a 3. Otherwise, go to the next step. If the district is north, return a 2. Otherwise, go to the next step. If the district is south, return a 1. And the hardest part about this is all those damned parentheses. And you notice that the modern versions of Excel and other programs will color code them, so you know what goes with what. You know, the purples go with the purples and the greens go with the greens. Got a blue here. But again, that's a really handy nested function. And it sometimes takes a while to figure out, where am I missing a parentheses? Which parenthesis goes with the other parenthesis? You'll notice that if I look at this, I've got 4 parentheses ending this thing. The very last parentheses is actually the one that goes with this, the whole thing. The second to last, this forest green one, is the one that goes with this forest green one over here. The whole set of the first internal if function. Then I got a purple one, and that goes here. That's where its match is. The second internal nested if function. And then I've got, and I don't even know what the heck color that is, but it goes with the last if function. And then every single one of the if functions has their own parenthesis as well. You know, the logical test is in a parenthesis as well. Kind of ugly. Some of these take me a while to figure out how to do it exactly right. But once you got it and you know it's valuable, you don't have to do it again. I can copy and paste. I can copy down. It's pretty slick. Once you've solved a problem, you've got it. So I'm going to take a quick break and be right back.